Good morning students, welcome you all to e-learning classes of Alphors. Today we are going to learn quadratic expressions. Okay. Yes, before going to quadratic expressions, as we must know polynomial. Okay. Yes, what is a polynomial? Polynomial is nothing but an expression of the form f of x is equal to a0 plus a1x plus a2x square plus so on an x power n, where as n is non-negative integer and a0, a1, a2, an are real or complex numbers, such that an means leading coefficient should not be 0, therefore an not equal to 0 is called a polynomial in x of degree n. As here a0, a1, a2 so on an, or here a0, a1, a2, an are as called coefficients. Beta coefficients is a0 constant, an is called leading coefficient. Yes, now in this leading coefficient should not be 0, that's why it is a polynomial in x of degree n. Polynomial in x of degree n. Okay, now as f of x is equal to a0, this is constant polynomial. F of x is equal to a0 plus a1x is linear polynomial, but here a1 not equal to 0 because here leading coefficient is a1. Okay, f of x is equal to a0 plus a1x plus a2x square. This is a quadratic polynomial. Here clearly a2 not equal to 0. One more, as here f of x is equal to a0 plus a1x plus a2x square plus a3x cube, as it is called cubic polynomial. Here leading coefficient a3 not equal to 0. Okay, now we are going to discuss third case. Beta f of x is equal to a0 plus a1x plus a2x square. It is a quadratic polynomial, but leading coefficient should not be 0. Okay, now we have to define quadratic expression. Yes, if a, b, c are real or complex numbers, and a not equal to 0, then the expression ax square plus bx plus c is called a quadratic expression. If a, b, c are real or complex numbers and a not equal to 0, then the expression ax square plus bx plus c is called a quadratic expression. Okay, examples as x square minus 5x plus 6, as ix square plus 2 minus I into x, or 4x square. These are all quadratic expressions. Okay, next, a real or complex number alpha is said to be 0 A real or complex number alpha is said to be 0 of the quadratic expression ax square plus bx plus c if a alpha square plus b alpha plus c is equal to 0. Now in this case alpha is said to be 0 of as quadratic expression ax square plus bx plus c if a alpha square plus b alpha plus c is equal to 0. Okay, yes, you take one example. 1 is 0 of x square minus 2x plus 1. Okay, if you keep in place of x 1 beta 1 minus 2 plus 1, it is going to 0. That's why 1 is a 0 of quadratic expression x square minus 2x plus 1. As quadratic expression, this is 0 of a quadratic expression. Now we are going to define quadratic equation. Quadratic equation. Okay, if a, b, c are real or complex numbers and a not equal to 0, then ax square plus bx plus c is equal to 0 is called quadratic equation. Is called quadratic equation. If a, b, c are real or complex numbers and a not equal to 0, then ax square plus bx plus c is equal to 0 is called quadratic equation. Okay, here as we have to take two examples. As x square minus 2x plus 1 is equal to 0. X square plus 4 is equal to 0. As x square is equal to 0. These are as all are quadratic equations. As what is root, what is a solution? Root and solution both are same, are root. Next one, solution or root. A complex number, a real or complex number. Complex number alpha is said to be root or solution. Root or solution of ax square plus bx plus c is equal to 0 if a alpha square plus b alpha plus c is equal to 0. Okay, in this case we have to say alpha is a root or solution of this quadratic equation. The set of elements represent the roots of a quadratic equation is called its solution. That is nothing but root. Okay, as for example x is equal to 1 is a root of x square minus 2x plus 1 is equal to 0. As x is equal to 2 is a root of x square minus 5x plus 6 is equal to 0. Okay, now this is called root or solution, both are same. Okay, the 0 of a as quadratic expressions are same as the roots of the quadratic equations. The zeros of quadratic expressions are same as the roots of the quadratic equations. 0 means it is for as expression as alpha, as that is what alpha is a 0 of quadratic expression ax square plus bx plus c if a alpha square plus b alpha plus c is equal to 0. As a complex number alpha is a solution or root of ax square plus bx plus c if a alpha square plus b alpha as plus c is equal to 0. Therefore the zeros of a quadratic expressions are same as the roots of a quadratic equation. Okay, we are going to find the roots of a quadratic equation. Okay, standard form of quadratic equation. standard form of a quadratic equation ax square plus bx plus c is equal to 0. This is standard form of a quadratic equation. Now we are going to find the roots of the quadratic equation. The roots of ax square plus bx plus c is equal to 0 or minus b plus or minus under root of b square minus 4ac by 2a. As roots are minus b plus or minus as under root of b square minus 4ac by 2a. Okay, as proof of this beta, as a solution, the given quadratic equation, ax square plus bx plus c is equal to 0. The given quadratic equation is ax square plus bx plus c is equal to 0. Multiply both sides with 4a. 4a of ax square plus bx plus c is equal to 0 into 4a, 0. Now what is this? 4a square x square plus 4ab x plus 4ac is equal to what? 0. Now it is in the form of 2ax whole square plus 2 times of 2ax of b, as I will add b and subtract b plus 4ac is equal to 0. Okay. Now first 3 terms, as look here, these first 3 terms as we have to write in the form of perfect square, 2ax plus b whole square minus b square plus 4ac is equal to 0. Okay, as 2ax plus b whole square is equal to, as taken to right side, b square minus 4ac. That implies 2ax plus b is equal to plus or minus square root of b square minus 4ac. Now this implies x is equal to 2ax is equal to minus b plus or minus under root of b square minus 4ac, as that implies x is equal to minus b plus or minus root over b square minus 4ac by 2a. Now as these are roots of as our standard as quadratic equation ax square plus bx plus c is equal to 0. Therefore, as the roots of ax square plus bx plus c is equal to 0 or minus b plus or minus root over b square minus 4ac by 2a. Okay, these are roots of as a standard form of quadratic equation ax square plus bx plus c. Here we have 2 roots, minus b plus root over b square minus 4ac upon 2a, and other is minus b minus root over b square minus 4ac by 2a. Alpha beta are 2 roots of ax square plus bx plus c. If alpha beta are 2 roots of ax square plus bx plus c is equal to 0, then sum of the roots alpha plus beta is equal to minus b by a, and product of the roots alpha beta is equal to c by a. Alpha beta is equal to c by a. Yes. Now as we know already roots of quadratic equation, as the roots of ax square plus bx plus c is equal to 0 or minus b plus or minus root over b square minus 4ac by 2a. Yes, now you take let alpha is equal to first root minus b plus root over as b square minus 4ac by 2a, and beta is equal to minus b minus root over b square minus 4ac by 2a. Yes, now we have to find alpha plus beta. First one, alpha plus beta, sum of the roots. As first one is minus b plus root over b square minus 4ac by 2a, plus of minus, this is a plus of, right? This is minus b minus root over b square minus 4ac by 2a. As take LCM, here LCM is 2a. Now this is minus b plus root over b square minus 4ac as plus of minus minus. This is also minus root over as b square minus 4ac. Now these two are going to cancel as we get minus 2b by 2a as we are getting minus b by a. As now this is nothing but sum of the roots, always minus b by a, as this is nothing but minus x as coefficient, that is nothing but what, as coefficient of x by coefficient of x square, minus as coefficient of x by as coefficient of x square. This is sum of the roots, minus b by a. Next, product of the roots. Next, second one is product of the roots, in the sense alpha beta. You know alpha is what, minus b plus root over b square minus 4ac by 2a into beta minus b minus root over b square minus 4ac by 2a. Now very clear, it is in the form of a plus b into a minus b. A square means minus b whole square, minus b square means root cancel, that is b square minus 4ac. 2 into 2, 4, a into a square. This is what, b square minus b square minus into minus plus 4ac by 4 a square, b square cancel. This is 4ac by 4a, 4 cancel, as 1a cancel, as now we are getting c by a. Therefore product of the roots is c by a. Therefore sum of the roots always alpha plus beta is minus b by a, and product of the roots alpha beta is equal to c by a. C is what, constant by coefficient of x square here, as constant by coefficient of x square. Yes, now this is sum of the roots, and this is what, product of the roots, alpha beta is equal to c by a. Okay, next one. If alpha beta are roots of a x square plus bx plus c is equal to 0, then a x square plus bx plus c is equal to a times of x minus alpha into x minus beta. Yes, here this quadratic equation ax square plus bx plus c as can be written as a times of x minus alpha into x minus beta. How? As you know alpha beta are roots of, as since alpha beta are roots of a x square plus bx plus c is equal to 0. Therefore sum of the roots minus b upon a, and product of the roots c upon a. Yes, now as a x square plus bx plus c is equal to, okay, as we have to take a common, because we have to get minus b by a somewhere here, c by a somewhere here, as that's why as I took a common, this is x square plus b by a of x plus c by a. This is a times of, this is x square. What is b by a? Minus of alpha plus beta, minus of alpha plus beta times of x, c by a alpha beta, alpha beta. Once you multiply, this is a times of x square minus alpha x minus beta x plus alpha beta. From this, as we are getting x is common, x of x minus alpha. From this we are getting as minus beta is common, x minus alpha. Therefore a times of x minus alpha into x minus beta. Yes, if ax square plus bx plus c is equal to a times of x minus alpha into x minus beta, then alpha comma beta are roots of ax square plus bx plus c is equal to 0. Or if alpha beta are roots of ax square plus bx plus c is equal to 0, then ax square plus bx plus c can be written as a times of x minus alpha into x minus beta. Equation. The quadratic as equation whose roots are alpha comma beta is the quadratic equation whose roots are alpha comma beta is x minus alpha into x minus beta is equal to 0. The quadratic equation having the roots alpha comma beta is x squared minus alpha plus beta into x plus alpha beta is equal to 0. As this implies x squared minus s1x plus s2 is equal to 0. As s1 is nothing but what are sum of the roots, s2 is product of the roots. As therefore the quadratic equation having the roots alpha beta is x squared minus sum of the roots into x plus product of the roots is equal to 0. That is nothing but x squared minus s1x plus s2 is equal to 0. Nature of the roots of a quadratic equation. Nature of the roots of quadratic equation a x square plus bx plus c is equal to 0. Yes, now nature of the roots always depend upon discriminant. Now what is discriminant? If as ax square plus bx plus c is equal to 0 is a quadratic equation, then b square minus 4ac is called the discriminant. Is called the discriminant of ax square plus bx plus c is equal to 0. Yes, it is denoted by delta. It is denoted by delta, and therefore delta is equal to b square minus 4ac. Now the nature of the roots always depend upon this delta. Why? Because x is equal to what? Minus b plus or minus root over b square minus 4ac by 2a. Yes, in that b square minus 4ac is what? Discriminant. It is denoted by delta. Yes, now we have to look here. A, B, C are here. Yes, we have two cases. As first one, case 1, let A, B, C or real. Let A, B, C or real. Now in this first one, delta greater than 0 means what? Discriminant is positive. In this case, roots are realigned distinct. Second one, delta is equal to 0. In this case, roots are real and equal to minus b by 2a, because delta is going to 0. And third one, delta less than 0, as roots are non-real complex numbers, non-real complex numbers and conjugate to each other. Conjugate to each other means roots are non-real complex numbers and these complex numbers are conjugate to each other. What is conjugate to each other means as if one root is alpha plus I beta, then other root is alpha minus I beta. You know very well, as if it is z, it will become z bar. As one root is alpha plus I beta, then other root is alpha minus I beta, meaning is the roots are non-real complex numbers and conjugate to each other. So now come to next case, case 2. Let A, B, C are rational numbers. A, B, C are rational. As in this case we have to discuss as delta greater than 0 means discriminant is positive and b square minus 4ac is perfect square. Perfect square. In this case roots are rational and distinct. In this case roots are rational and distinct. Second one, delta greater than 0 and b square minus 4ac is not perfect square. Not perfect square. In this case roots are irrational. Roots are irrational and they are conjugate sets and they are conjugate sets. What is the meaning of conjugate set? If one root is a plus root b, other is a minus root b. This is the meaning of conjugate sets. If it is a minus root b, other is what? A plus root b. And the remaining two cases are same, as delta is equal to 0, as roots are rational and equal to what? Minus b by 2a. And the fourth one, delta less than 0. Roots are non-real complex numbers. Complex numbers and conjugate to each other. Conjugate to each other. Means one root is 1 plus I, other root is what? 1 minus I. 1 minus I. Now, next one is transformation of equations. Transformation of equations. If f of x is equal to ax square plus bx plus c is equal to 0 is a quadratic equation whose roots are alpha comma beta, then the quadratic equation having the roots, is first one. Having the roots is first one 1 by alpha comma 1 by beta. Now it is a quadratic equation having two roots alpha beta. Then the quadratic equation having the roots is 1 by alpha comma 1 by beta, means reciprocals of this two roots. In this case, transformed equation will become f of 1 by x is equal to 0. 1 by x is equal to 0. How we got this result means let one root consider x, that implies what is alpha is equal to 1 by x. Since alpha is a root, therefore f of alpha is equal to 0, as in place of alpha we have to insert 1 by x, that is f of 1 by x is equal to 0. The second one, as alpha plus k beta plus k, means as each root is increased by k, then the transformed equation f of x minus k is equal to 0. How? As let you take one root x plus k is equal to x plus alpha plus k is equal to x, that implies alpha is equal to x minus k. Since alpha is a root, therefore x minus k is also root, f of x minus k is equal to 0. Third one, alpha minus k beta minus k, means what? Each root is decreasing by k. Yes, in this case f of x plus k is equal to 0. In this case, as one root alpha minus k is equal to x, as implies alpha is equal to x plus k. Since alpha is a root, therefore x plus k we have to substitute in place of alpha. And fourth one, as minus alpha minus beta, means what? Whose roots are as opposite in sign, or contrary sign. As in this case, our transformed equation will become f of minus x is equal to 0, because let minus alpha is equal to x, that implies alpha is equal to what? Minus x. Fifth one, whose roots are multiplied by k, that is nothing but what? Alpha k beta k. In this case, our transformed equation will become f of x by k is equal to 0. How, sir? This let alpha k is equal to x, this implies alpha is equal to what? X by k. These are transformed equations. Now, as whose roots are squares of the quadratic as equation, squares, as means alpha beta roots of this. What is quadratic equation having roots are alpha square beta square, is nothing but f of root x is equal to 0. Yes, this is very clear. You take alpha square is equal to x, alpha is equal to what? Root x. Okay. As next one, whose roots are cubes of the roots of the quadratic equation, means alpha cube beta cube. In this case, f of cubic root of x is equal to 0. As just you take a letter alpha cube is equal to x, that implies alpha is equal to x power 1 by 3, in the sense cubic root of x. These are as transformed equations of a quadratic equation. Okay, this is our original quadratic equation whose roots are alpha beta. Then the quadratic equation having the roots reciprocals f of 1 by x, each root is increasing by k, f of x minus k is equal to 0. Each root is decreasing by k, f of x plus k is equal to 0. As each root having opposite in sign, f of minus x is equal to 0. Each root is multiplied by k, f of x by k is equal to 0. Each root is square of the roots of the given equation, then required equation f of root x is equal to 0. Each root is each root is a cube of the roots of the given equation. In this case, f of cubic root of x is equal to 0.